Good morning, everyone. Today we're going to be looking at linear equations, and specifically, what does it take or what does it require for us to be able to determine the equation of a line? In other words, in this specific case, can we determine the equation of a line given just its slope and a point that it runs through? Now, the answer to this is going to be yes, we can do this. But in today's video, we're going to really explore how. Now, if you've studied lines at all, you may be familiar with the fact that there are a few different major forms, a few different major ways that we can represent lines with an equation, and we're going to be working with two of those variations today, namely the slope-intercept form and the point-slope form. Now, I am going to assume that you have seen at least one of these before, but if not, the slope-intercept form is the equation y is equal to mx plus b, right, when our line is represented as y equal to some number times x plus some number. The point-slope form is going to be y minus y naught equal to m times x minus x naught. And as we work through these examples, I'll sort of explain what specifically each of those variables mean as we go, but I am going to kind of assume that you have at least seen both of these before. And we can use either of these forms in order to determine the equation of a line given its slope and some point. So let's first look with the slope-intercept form. So I'll keep this over here. We'll use y is equal to mx plus b. And let's take a look at an example where we have a line with a slope of 2/3 intersecting with the point -3, -4. So we are given a slope and we are given a point, and that is all of the information that we're going to need in order to determine the equation of our line. And we can use the slope-intercept form to do that. Now, of course, the way this works is this x and y represent all of the coordinate pairs, x and y, that belong to our line. This m represents our slope, and b represents the y-intercept. Now, we don't know anything about the y-intercept, so that's going to be one of the pieces we're going to have to find. But we were given some information about slope, right? Namely, the slope is 2/3. And so we know in this case that m is equal to 2/3. Okay, and so we would be able to plug that piece of information in. M is equal to 2/3. And so far, we have y is equal to 2/3 x plus b. Now we're also given another piece of information, and that's that we intersect with a point -3, -4. Because of the nature of this equation, right, all of these xy pairs have to be pairs that belong to our line. Well, -3, -4 is going to have to be one of those pairs as well. So we know that -3, -4, or x equal to -3, y equal to -4, has to work for this equation. And so since this x and this y can represent any of the coordinate pairs that work, why don't we choose that one -3, -4? And so we can substitute those in as well and say that -4 would have to equal 2/3 times -3 plus b. And this is really good because now we have an equation with a single variable, right? Just this b left over that we can now solve for. And so that is why all that we need is the slope and the point, because the slope plugs in for m, the point can plug in for x and y, and then we're able to find the one remaining piece of information, our y-intercept. And so let's actually solve this out and see how this works. First things first, when we're solving an equation, we can simplify both sides of the equation. And on our left-hand side, that's going to remain -4. On our right-hand side, we have 2/3 times -3. Now, you may remember when you're adding fractions, you can think of this as 2/3 times 3/1. And so we can do a little bit of cancellation here because we have a 3 on the top and a 3 on the bottom. once we've canceled those out, when we multiply across, we'll have 2 over 1 on the top divided by 1 times 1, or sorry, 2 times 1 on the top divided by 1 times 1 on the bottom, in other words, equal to 2. And so we have negative 4 is equal to negative 2 plus b. Isolating b, we can add 2 to both sides to get rid of that minus 2. And that's going to give us negative 4 plus 2, or negative 2 equal to b. And now we have enough information to write our line in slope-intercept form more generally. And so we can say, therefore, y is equal to m, or in our case, 2/3, x plus b, or in our case, negative 2. Now, because we have plus negative 2, it's probably best that we write this a little more simply and just say minus 2, but that's how we can use the slope-intercept form to find the equation of our line. Line with a slope of 2/3 that intersects the point negative 3, negative 4 is going to be y is equal to 2/3 x minus 2. And that's one way we can determine the equation of a line given its slope and a point. Now, that's not the only way we can do this, however. We could also make use of the point-slope form. We could also make use of y minus y naught equal to m times x minus x naught. Now, in this equation, we have some similar things and some new things. Just like last time, we have a slope of m, which again in this case is going to equal to 2/3. But in this case, we also have this y naught and x naught. Now, x naught, y naught just represents some specific point that our line intersects. And so some specific point that our line intersects can be negative 3, negative 4. And that's really all we need for this one. And so in some sense, this one might be easier because we don't need to worry about the y-intercept at all. It's going to work its way out in the end. And so we can take these two pieces of information, our slope equal to 2/3, our x naught, y naught equal to negative 3, negative 4, and we can plug those in to our equation. And so we have y minus y naught, or y minus negative 4, equal to m, or 2/3, times x minus x naught, or negative 3. In order to solve for y, we'll start by simplifying both sides. On the left, we have y minus negative 4, or more simply, y plus 4. On the right, we have x minus negative 3, or x plus 3. On the right, we can further simplify by distributing that 2/3. And so that's going to give us 2/3 x plus 2/3 times 3. Just like last time, the 2/3 times the 3 over 1, dividing by 3 and multiplying by 3 are opposite actions, so those will cancel out. And so we have 2/3 x plus 2. And then to solve for y, we can isolate it by subtracting 4 from both sides, and that's going to give us y on the left equal to 2/3 x plus 2 minus 4 gives us minus 2 on the right. And so you'll see that this works out to be exactly the same, either form that we use, either method that we use. And so we can say, therefore, y is equal to 2/3 x minus 2. And again, this represents a line that has a slope of 2/3 and runs through the point negative 3, negative 4. And we can verify this on a graph, right? If we graph y is equal to 2/3 x minus 2, we'll see that that does in fact intersect with the point negative 3, negative 4. We can also verify that this has a slope of 2/3 if you remember that the slope represents the rise over the run. So in the case of a 2/3 slope, we would have a rise of 2 and a run of 3. So if we go up 1, 2, and over 3, we'll find ourselves at another point on this line, namely 0, -2. And so we can verify visually that our equation does in fact graph this line. Thank you for submitting your question. I hope you found this helpful. If you do have any more questions, feel free to put those in the comments below. But otherwise, thanks for watching and have a great rest of your day.